When we discuss animal behavior, it really is what probably comes to mind for you. It's the behavior of animals, right? So we need to think about what kinds of behaviors these animals exhibit. Now, many of these concepts will be familiar to you, but you may not have the terminology to go along with the actual concept and to put it together into biological kinds of terms. So that's our job today. We want to think about these basic behaviors and how we apply biology to them. And then later on, what we'll get into is how the environment can influence those behaviors. So our big question for these couple of lectures is, why do animals behave as they do? What makes them do particular things the same way almost every time? Okay, so the first one we want to look at is kinesis. This is probably the most familiar to you. It is simply the ability of an animal to move in response to some sort of stimulus. Now, this could be simply that the animal starts or stops walking or moving. If you startle an animal, it tends to just stop in its tracks, right? Okay, that kind of thing. You could make it go faster or slower, so simply changing speed in its response. It may run, or it may slow down, or it may try to hide, right? The other thing that a lot of organisms do is change direction. So kind of sometimes like zigzagging motions rather than moving in a straight line. All of these things are in response to something going on in their environment. Now, these random movements are different than taxis. Taxis is a very directed response to something in the environment, either toward it or away from it. Okay, so toward the taxis or toward the stimulus would be positive, away from it, negative. And the whole idea is trying to find the ultimate source for a lot of these organisms of food, shelter, any other thing that they need. So you would move towards those kinds of things, and of course you would move away from anything like predators or negative conditions in the environment, those sorts of things, right? So when we look at these different taxis kinds of movements, so if we look at the trout in the bottom corner here, we're actually looking at them moving upstream, and so their goal, of course, by moving upstream, the current is moving in the direction of the arrow here, so they're swimming against the current, but their goal is to get to the calm waters at the top of the stream, the pools, to actually lay eggs, right? To breed and lay eggs. So those are the goals for them, and they know by swimming against the current that they will find those places. As far as their ability to navigate, animals are very good at spatial learning. So essentially this is landmarks. Think about how you give someone directions to your house. Do you always use the road names, or do you use things like gas stations or restaurants or old houses on corners to give people orientation, right? Animals are very, very good at this for finding food, nesting locations, mates, and sometimes we look at hazards, right? So any of these things can be used to kind of navigate to or away from particular sources in the environment of things they need. Many studies have been done. This is with the digger wasp, and trying to understand how they find their particular nesting site, because they nest below ground. So how do they find their way back to their nest after being out during the day? And the idea is they've oriented themselves to that particular landscape, to something in the environment. Scientists set up these kind of pineapple-looking things, right? They're not pineapples, but these little bush things, and then they surrounded the nest. When the bee or wasp here left the nest, they moved those over to the other side where there is no nest, and the bee automatically came back to that location, that was marked by a landscape. Okay, so in this case, kind of tricking the wasp, right? But in a way to understand that they really are orienting based on things in the environment. So what causes these kinds of behaviors? We have two different causes. One is what we call proximate. So this is something that is going to cause the behavior to occur because of some sort of function of the animal. So it could be hunger, it could be hormone levels that signal that it's time to mate or to migrate. Ultimate cues, however, we look at as being linked to survival and reproduction directly. So those would be immediate, in front of you, you need to respond to the situation kind of cues. Okay, so a little bit different. And when we look at them over time, we know that those kinds of cues are going to have huge effects on not only natural selection, so evolution, but also on an organism's motivation for a particular stimulus. So things like what we call innate behaviors. So these are behaviors that you do without even really thinking about doing them. So this is things like your internal clock, or courtship rituals or mating rituals in organisms. You just kind of do these things, right? These are different than things that you're going to learn or recall from memory, and we'll look at those. And then we also have to look at things like environmental influence, because as soon as the environment changes, you're going to have to deal with all kinds of different behaviors associated with that. So briefly, let me just show you a genetic predisposition to learning. So what we look at in the spiders is that spiders are born with the innate ability to build a nest. Okay? Now, if we look at their ability to build that nest well, they actually have to be trained by their mothers. So they're born with the ability to spin a web. But what they found is if they lack teaching by their mothers or by watching another spider, their web is poor, and they actually won't catch any prey items. So this hardwired, innate, born sense to spin a web is there. You just have to tweak it. You have to modify it and kind of groom it so that it works to the advantage of the organism. This really falls in line with things like reflex type behaviors. So your reflex behavior is an automatic response to something. All right, so you step on something sharp, what do? You lift your foot, right? Pretty quickly. That's your reflex behavior to a particular thing. You touch something hot, you pull your arm back, all of these kinds of things, okay? Now, some of these are guided by internal influences. So these are behaviors that are not taught. But then we also have something known as stereotype responses, where regardless of ever being taught anything, you are going to respond in the same way as every other organism of your species. Now, this is a bizarre set of responses, but it really is things like you step on something sharp and you move your foot, okay? If you hear your alarm go off, at first, we look at you having a very stereotypical response to it, and you smack the top of your alarm clock, right? We'll look at how that changes as you learn about your alarm clock. We also have things known as fixed action pattern behaviors. These are pretty complex. The gray-lag goose, this guy here, actually has very, very stereotypical responses and very fixed patterns of behavior to particular stimuli. And in particular, what they're trying to do is keep their eggs inside their nest. But it turns out that as soon as that egg is located outside of the nest, the mama goose will go over and with her beak roll it backwards until it's back into her nest again. You see how she kind of pushes it backwards into her nest. Well, it turns out that she will do this with absolutely any object that is round. And scientists had a good time with this one with those plastic balls from the ball pit at Playlands. okay? And they surrounded gray-lag goose nests in these balls, and they continued to try to roll them into the nest. Not very nice, but it got the point across that they really are going to continue this pattern until they reach that finale of having all of these things inside their nest. The same is true with our sticklebacks I have here. Sticklebacks have this color morphing ability. So you see this one very kind of silver plain. This one has a very red underbelly. So the confrontational state of the sticklebacks is actually this red coloring. So what they wanted to see is whether or not that red is actually the cue, or if the organism is putting out some sort of other stimulus as well, or some other response mechanism. And what they found when they made a whole bunch of clay fish, so they made one that was very plain, no red, and there was no response. They made one that was fish-shaped again, red belly. The other fish took up a threat posture kind of thing. The other, when they started to play around this a little more, they took the fins off, so you have kind of just this oval shape, right, with a red belly. And then kind of a more squish shape with a red belly, and then eventually really just sort of nothing that resembles a fish, but it still has a red belly. So in every case, they get that threat position. So it's not the fish, it's not the shape of the fish, it's not any hormone that the fish is producing. It's all about that red belly. And so we see with a lot of these fixed action patterns, the response doesn't matter what it is, as long as it resembles the original target or stimulus to which the response is being made. That's all that matters.